Good day, Cass. Welcome once again to another session of differential equation. And now we are on the application of first order, first degree differential equation. And we've last meeting or last session, we've discussed about the types of trajectory. And the first trajectory, or the first of the two types of trajectory we've discussed, is about isogonal trajectory. Okay, so isogonal trajectory, as again mentioned in the last session, is that isogonal trajectory are those trajectory which has an angle not equal to 90 degrees. So if you have isogonal trajectory, then you will be using the angle between, or in order to solve the slope, you need to get the slope of the two trajectory of those two lines. So last meeting, this is what we've discussed. Okay, as mentioned, isogonal trajectory is the angle is not equal to 90 degrees. Now, the second type of trajectory that we will be discussing, which will be covered for the whole application of the whole geometric application, is the orthogonal trajectory, which is that the angle will be equal to 90 degrees. So let's try an example. Okay, so now orthogonal trajectories of the ellipse. So find the orthogonal trajectories of the ellipse. So from here, we are given with this equation. So the equation is 4x squared plus y squared equals cx. So in your integral calculus or in your other subjects, you are taught how to graph the given, or how to graph equations, right? So those who are under me and under Sir Kausin, I'm very sure that you are taught how to graph these types of equations. So the illustration or the graph of this equation is an ellipse. So this ellipse or this equation will form this type of ellipse. Now, the problem is that find the orthogonal trajectory of the ellipse. So meaning there is a trajectory curve, or this orthogonal trajectory, that passes through that ellipse, and the angle between them will form 90 degrees. So from here, so this one and this one, so the tangent line that passes between them, the intersection, this is tangent point. So this is the tangent line, and so this is the normal line. So the 90 degrees of the tangent line. So from there, you can form, this one can form a 90 degrees angle. So from this ellipse until this one can form 90 degrees angle. So what we are asked now is to find the slope or the equation of the orthogonal trajectory. So here you need to find the orthogonal trajectory of the given ellipse. So here we are given with this equation. So same process what we do in isogonal. So there's no difference. Okay. So let me find paint. Okay. So from here, okay, so from here, what we'll need to do is partly the same as what we always do in what we done last meeting in our isogonal trajectory. So, right now we are on the orthogonal. So, orthogonal trajectory. So, okay, so we are now on the orthogonal trajectory. And our problem have an equation of 4x squared plus y squared equals cx. So, what you need to do is to derive this one with respect to x as your denominator. So, you have to derive this one. So, you have to derive the given equation. So, derive that one. So, you have derivative of 4x squared to dx plus derivative of y squared with respect to dx was derivative of cx with respect to dx. Okay, after that, after deriving that one, so obviously, the derivative of this, derivative of 4x is 2x dx over dx plus derivative of y squared, that is obviously 2y dy over dx equals derivative of this one, c is a constant, so derivative of x is dx over dx. So now, let me enlarge this one. Okay, so, oops. So from here, so we could cancel this one. So we could cancel this one and this dx. So therefore, what remains is 2x plus 2y dy over dx equals c. So our target here is to get the slope of the 4x plus y squared equals cx, like what we've done, or like the process of isogonal. So from there, we just transpose your 2x, so you have 2y dy over dx equals c minus 2x. So after that, okay, sorry, that is not 2x. So that is 2 times 4, that is 8. Sorry. So let me erase this one. Okay, sorry, this should be... Oops. Okay, now, so derivative of 4x squared is 8x. So you have 8x. So this one is 8x. So now, what we need to do is just to divide this c minus x with 2x, so to get the slope. So you have dy over dx will be equal to the c minus 8x over 2y. So this is your first slope. So this is the slope of the 4x squared plus y squared. So from here, so we get our slope. So if you could see, this is our slope. Okay, this is our slope. So okay, so as I've written here, since, remember, since this is 90 degrees, therefore that is perpendicular, diba? When we say perpendicular, so you have like this. perpendicular, which forms 90 degrees. So that is perpendicular. So if you have perpendicular, remember that in analytic geometry, when we say perpendicular, the slope of the second slope, or the slope of the other curve, is the negative reciprocal of the first curve, or vice versa. So if we have this one, so you have slope of the other one is the negative reciprocal of the other slope. So we could interchange this one, so we will still have this. So, and if we have a parallel, so the slope 1 is equal to the slope 2. Right? So that is the principle in analytic geometry. Okay. So okay, that's how it works here. So since our trajectory for orthogonal trajectory is always 90 degrees, so that is literally 90 degrees. So that is actually a 90 degrees. So therefore, if we say that this is our slope, let's say this is our slope 1. So let's say this is just our slope 1, or slope 2 ba. So we, in order to get the slope of the trajectory, so we just need to get the, if this is the slope 1, this is slope 2, so we just need to get the negative reciprocal of slope 1, or the one that we derive. So from there, we just need to get the, and we are solving in differential equation, or in differential calculus. So therefore, we know that we have to use the symbol for the slope as dy over dx. Okay, dy over dx, which is equivalent to negative 1. What is our slope? So let me box this one. So this is the slope. So from there, we'll just put it here, c minus 8x over 2y. After that, just simplify it further. So you have dy over dx is equivalent to negative 1 multiplied by 2y over c minus 8x. So just transpose this one. This becomes a numerator, and this is denominator. Then multiply it negative, so that it will be just a fraction, a numerator and denominator. So from here, so we have dy over dx is equivalent to negative 2y over c minus 8x. So from this given, so diba, after we use the tangent theta in isogonal, after that we integrate. So the same process here. After we get the slope of other curve, the slope, we need to get the equation, diba? We are asked, or we are tasked to find the trajectory, the isogonal trajectory. So from here, this is the slope. So we could get, by integrating this one, we could get the equation of the orthogonal trajectory. Sorry. So from here, what can we use here? So first, let's try the hardest one. Simultaneous. There's no two equations, so simultaneous is x. Hindi siya pwede. So if we have Bernoulli differential equation, this equation will not form a Bernoulli differential equation. If we use linear differential equation, this will not form a linear differential equation because you don't have p of x, right? Or p of y. Then, if we use exact differential equation, maybe we could try.